So, what I want to do today is to go over some other techniques you can use to balance equations. So, I want to show you an algebraic technique, which will work with any equation. Now, this technique does take a little while to do. So, I would only do this if you really are completely stuck. And you may want to practice on some pretty easy equations just to get the hang of it before you attempt it with a more complex equation. So I'm going to show it to you with two different equations, and these were on one of your sheets that you did for homework. So let me show you the technique. The first one I'm going to do is a pretty easy equation, and then we'll do on a more complex one. So when you're doing this, what you do first is you assign a variable for each of your coefficients. So I'm just going to assign A, B, C, and D, and you're going to be solving a series of equations. So we're going to solve one equation. One equation will be terms of nitrogen, the other one will be terms of hydrogen, and then oxygen. So we will have three equations. So for equation for nitrogen, we know that we have one nitrogen here, so we would say A times 1 is equal to A is equal to, and then over here we have two nitrogens, so we're going to say 2C. We're going to do the same thing for hydrogen. So we have three hydrogens in this compound, so we'll say 3A is equal to 2D. And then we have our last equation, which will be for oxygen, so 2B is equal to D. Okay, so the next thing that we're going to do is we're just going to randomly choose a number, and I'm just going to assign it to one of these variables. So I'm going to assign a number A, it will be equal to 1. If I do that, this means that C will equal to, so 2C would equal to 1, if that's true, and then C would equal to 1/2. Likewise, if I look at my second equation, if I put A is equal to 1 with that equation, I would have 3 times 1 is equal to 2D. So D is equal to 3/2. And then if I look at my last equation, if I know that D is equal to 3/2, I would say 2B is equal to 3/2. So B is equal to 3/4. Okay, so I could then put these in as my coefficients. So A is equal to 1, B is equal to 3/4, C is equal to 1/2, and then D is equal to 3/2. Now, to make these all whole numbers, I can multiply each of these coefficients by 4 in order to make this a whole number. So this would become 4, this would become 3, this would become 2, and then this would become 6. Okay, so that is, and if you check this, you should see that these answers do work. Okay, so let's do another problem. Let's do number 10. So 10 was pretty tricky, but I wanted to show you how this technique might have helped you to solve this for the variables. So let me go down to number 10. Okay, so we have this equation here. So in this equation here, again, I'm going to solve a series of equations. So I'm going to make each of these a variable, so A, B, C, D, and E. And I'm going to set up an equation for each of my elements in my reactions. So I'll have one equation for copper. So A will have to equal to C. I'll have another equation for hydrogen. So B will have to equal to E. Another equation for nitrogen. So B will have to equal to 2C plus D. And then for oxygen, so 3B will have to equal to 6C plus D plus E. Okay, so when we get to this point, I want to show you how I would approach this, but there are many different ways you could probably solve these series of equations. So again, this will just take some practice. So in this situation, I notice that I have two equations at the bottom here in terms of B. So I have B is equal to 2C plus D, and then 3B is equal to 6C plus D plus E. So I'm actually going to set these equal to each other. But before I do that, I'm going to multiply this equation here by 3. So I'm going to multiply that equation by 3. So when I do that over here, I get 3B is equal to 6C plus 3D. So now these two equations are in terms of 3B, are equal to 3B. So now I'm going to set them equal to each other. So I have this 6C plus 3D is equal to 6C plus D plus E. When I do this, I now see I have 6C on each side, so I can get rid of that. And now I have an equation just in terms of D and E. So now I have 3D is equal to D plus E. And now I can get the D's on the left-hand side of the equation. So 2D is equal to E. And now I know that E is equal to 2D. Once I've done this, I now have fewer equations or fewer variables. So now I'm just going to randomly decide maybe that E is equal to 2. If is equal to 2, I could say, well, D will then equal to 1. And then I could say that if E is equal to 2, B is equal to 4, using this equation over here. Now I have essentially two more variables now, A and C. So I want to solve for those. So I'm actually going to use this equation here again to now get it in terms of, get a number for C. So using this equation here, if B is equal to 4, I could substitute 4 is equal to 2C plus 1. So now I'm going to solve it for C. So 3 is equal to 2C. So C is equal to 3/2. Now I could plug this number into this equation here. So this means that A is also equal to 3/2. So now I have a number for each one of my variables, and I'm going to now plug that into my equation. So I know that A is equal to 3/2, B is equal to 4, C is equal to 3/2, D is equal to 1, and E is equal to 2. To get these all to be whole numbers now I can multiply each of these coefficients by 2. So this becomes a 3, this becomes an 8, this becomes a 3, this becomes a 2, and this becomes a 4. And if you try these out, these should all work. So this is just a technique of solving a series of equations to find the coefficients for your equation to make it balanced. Okay, so like I said, I would practice this maybe with some easy equations to get the hang of it if you want to be able to use this as a tool. Otherwise, usually if you persist long enough, you should be able to balance it without using this techniques. But I would only use this if I were desperate.